I wish I had learned this about diffraction gratings earlier. Well, actually, I did learn this earlier thanks to my supervisor, but that would be a terrible hook for a video. There will be no formulas here, just how you can actually see the diffraction and quickly estimate whether it appears or not. That will be especially useful if you work with any kind of periodic structures. Diffraction on a periodic grating is something you can observe at home. Take a CD or DVD. Get some extra virgin oil and pour it into a transparent container. Now take a laser pointer. You'll notice the laser beam is clearly visible inside the oil. Next, shine the laser through the oil onto the disc. You'll see not just one reflected ray, but 5. These extra beams called diffraction maxima or diffraction orders. Where do these extra beams come from? The explanation is actually a bit tricky. But first, let's take a closer look at the CD itself. Under a microscope, a blank CD looks like a series of equally spaced tracks. But a CD that has a data on it looks like the one on the right. But it doesn't matter now. The distance between the tracks is about 1600 nanometers. The diffraction orders arise due to sophisticated interference of waves reflected from each track. So, this set of tracks can actually be treated as a diffraction grating, and the beam simply undergoes diffraction on it. You will find a detailed explanation in another my video, but here I will just show a really cool trick that lets you find the diffraction orders visually. No calculations needed. Let's start by drawing the grating. Its period is 1600 nanometers. That's the distance between the tracks. Next, we draw a circle with radius equal to the grating period. Now we add the incoming and the transmitted light rays. Now let's do something a bit unusual. Remember that light is a wave and it has a wavelength. So we draw vertical lines spaced by the wavelength, in our case 650 nanometers. Surprisingly, the diffraction orders will point exactly where these vertical lines intersect the circle. This is a super useful trick if you want to quickly estimate whether diffraction maxima will appear at all and how many of them you have. But what I showed here is a very specific case. In reality, this method can be extended to the angular incidence 2D and even 3D gratings. As for why this trick actually works, you will find the full explanation in another longer and a bit nerdier video that covers all the details. The link will appear in the top right corner and in the description below. I would also like to point out that in oil, the diffraction orders don't go in the same directions as they do in air. This whole setup is a bit clumsy. You have to take into account refraction in the oil, the curvature of the container, and the fact that, well, I'm a theorist and my hands are not exactly made for experiments. One more interesting thing I wanted to mention. We see the laser beam in the oil not just because of scattering, but also because of another effect called fluorescence. For example, a violet flashlight actually also turns red in oil. And the same goes for green lasers. However, I don't have one right now. Also, extra virgin oil gives a much stronger effect than regular oil. I hope this video was interesting and useful.